In this video, I'm going to be going over routing for a double-sided board, a two-layer board. The one that you completed already is a single-sided board. But in this case, at some point we want to see if we can order double-sided boards. And you'll find out that these will be a lot easier to route. It's important because sometimes you need to do a single-sided board depending on the cost factor. But double-sided boards you'll find a little bit easier to route. But I wanted to go through the previous process. So I'm going to go back and change a few things. And the first thing I'm going to do is change back the terminal block to a large or a smaller size rather. So if I delete the terminal block here, I'm going to go ahead and add a Phoenix 3.5. That refers to the spacing between the pins. So 3.5 millimeters. So I'm going to place that on there and move this here and make sure that I'm connected. Sometimes just moving a net onto a pin doesn't always make a good connection. And you can use the eyeball command to make sure that they're connected. It's not called eyeball. What is it called? Show. It looks like a little weird eyeball. But I can see that the connections are good because the pins are lighting up pink there when I click on it. Okay. So I'm going to go back to the board here and move that over here. Now, the actual part number doesn't really make any difference, so I'm going to delete that. And I want to double check before I go any further that I'm on the have it oriented the right way. Now, if you look on the bottom left, you'll see that it says signal ground, but we've got those flipped. So I actually need to rotate that terminal block I've got move selected, and I'm going to right click twice and make sure that the signal that I'm looking at here, for example, that's the 9-volt signal and this is the ground, that I've got those connected correctly. The other thing I'm going to do is rotate the 4017 like this. Whoops. So that it's in the same orientation as the 555. That'll work a little bit better. If you don't see all the traces, you can hit rat's nest, and that will show all the other traces that might have been missing at this point. Okay, so now a few things I'm going to do. I'm going to try to compress the space on this. We'll find out with double-sided boards that we can get a lot more circuitry crammed into a lot smaller area. So I'm going to try to make this board a little bit on the smaller side. By the way, if you try to select a part and you're accidentally clicking the part number, make sure when you select it that you click in the center. That's a common problem that comes up. I'm going to move these capacitors over. I do want to keep the positive symbols in the same direction. If you'll remember from one of the previous PowerPoints, we want to make this circuit as easy to build as possible. But again, we are not as concerned about parts placement or trying to optimize things for routing, because with a double-sided board, you've got a lot more options for which way that the parts can be routed. Okay, so I'm going to just move this resistor over here for now. Move the 4017. And now you can already see I'm saving quite a bit of space as I am modifying the board. Now I'm going to move all these LEDs and the diodes, in fact the whole top of the board. I'm going to make this a little bit smaller. What I'm going to do is group the whole top part all at once and move everything down at the same time. You want to make sure when you do that your board isn't misaligned, because sometimes you'll get something like that where you kind of lose the fact that it's rectangular. You always want to make sure you have a rectangular board. I'm going to move the LEDs a little closer together here. It's kind of for aesthetics, trying to keep the same spacing between them. And I can even move some of the diodes down onto this side. Now, if you remember, if you went through the process of doing this as a single-sided board, you really had to spend a lot of time and figure out how to optimize that. And I wasn't just trying to make things difficult for you. because sometimes you do have to do a single-sided board. But you'll just start to see some of the advantages. The main reasons why this is going to be a lot easier. Let me grab this half of the board and slide it over. The reason it's a lot easier to router, not only because we can have traces on the top and the bottom, but because double-sided boards have what are called plated through holes, or and vias, that allow us to make connections between the top and the bottom. And that can save a lot of space. So let's see what my dimension is now. If I kind of slide over here, if I look at these numbers over here, we're at 2.5 by 2.1. That's pretty small. Now, what I could do if I wanted to, and you're welcome to do this, is you can make these LEDs smaller size. As I'm looking at this, it doesn't look too symmetrical. Let's see. I am at 2.1, so 1.05 would be the set up. Let's see here. 2.525. I'm going to make that dimension so that it's actually 2.5 inches. And then the top, I'm going to see if I can get down a little bit lower, maybe to 2 inches. I'm going to move this guy, these LEDs down a little. That resistor. I'm going to leave a little bit of clearance around the drill holes so that we don't run into anything down there. I could rotate these capacitors if I wanted to also to make them a little bit more uniform. One of the problems that you run into as you start doing more and more routing is trying to keep the silkscreen clean. That's kind of a challenge. And in fact, I'm going to rotate this diode this way a little bit. I usually like to try to keep the components kind of going in the same directions, but to save some space, I'm going to move it up there. Now to see where I'm at as far as the routing, I can click on Rat's Nest here, and it'll kind of rearrange those air wires, these yellow wires, to a position that will allow me to see where things are going to land a little bit better. And I've gained enough space here. I'm going to move this guy over here, or I can move the whole thing down again a little bit. And I'm not trying to be too obsessed with this, but I'm going to try to get it down to something more like 2 inches. So it's going to be a pretty small board when it's all done. See where we're at there. Okay, so that is 2.5 by 2 inches. That's a pretty small board. Now, as I was mentioning here, if we look in the center, now we're at 2.5 inches. So 1.25 inches will be the center. I'm just going to put a little mark here to keep track of where that is. 1.25 right there. That's kind of where I want to center my LEDs. So I'm going to move everything kind of over a little bit so it looks a little bit more symmetrical. Not perfect, close enough. Okay, I'm going to put a little more text here, my name. And I want to put that on layer 21, T place. And I'm going to put today's date. And I found that that's really helpful. In the boards that I've designed for industry, having the date on there is invaluable to know when it was manufactured, to keep track of it. Diodes are a little bit off here. I'm going to straighten them out. And the silkscreen, for the most part, looks pretty good. Some of the parts, the main thing you're looking at is not overlapping the silkscreen. And you can see this a little bit better if I go to View and turn off the air wires, which are layer 19. And that kind of helps you see the silkscreen a little bit better, and I don't see anything that looks too bad that's overlapping. Okay, now another thing I can do here is change the size of the LEDs. So these are T1 3/4, but I can actually go to Change, Package, and if I click on that LED, it gives me a lot of options here. So rather than deleting the part and then having to replace it, I can actually change it to a smaller size. So if you want to do this, you could do this for all the LEDs. For mine, I'm just going to leave it at the larger size, but if you want to go to a smaller size, you're more than welcome to do that. Okay, I'm looking at this now. The ground label needs to be down there. For the switch positions, you might have, if you want to put like a S and an F for slow and fast, maybe, to indicate what that switch does. That might be helpful too. I'm going to move that part number out of the way. Actually, I don't really care about it. I'm just going to delete it. Okay, so I'm pretty happy with this layout. Now I'm going to route it. Now, one of the cool things is that once we've move this guy one more spot here. Trying to count the spacing between these. Yeah, those look good. It's one of those things where if your LEDs like out here, it'd look a little funky. So take a little time to clean it up. Because once you commit, you've got that's what your design's going to look like. Okay, now we're going to route this board. And if you remember from the previous assignment, when you're doing a single-sided board, we're going to, we used a DRC design rule, actually called DRC. And we use the other mill DRC. This time what we're going to do is go to Load, and we're going to select the default. And that's in the, where this is stored is under this PC Documents Eagle Design Rules. That's the default location for that default file. And now we'll find that it's going to be, I click Apply, and it's going to be a lot easier to route this board. So let's see if you've been challenged with trying to route that the other board. You'll know it took a little bit of time to do that. Let's go ahead and see if we can route this now and how long it's going to take. So we're going to go to Auto Router. Now, this is important. We're going to route the top and the bottom. And I'm going to put Auto and change bottom to Auto. Sometimes you can, what those other lines represent, you can have a preference for which way you'd prefer to have the traces run, horizontal, vertical, but typically Auto is a good selection. And I'm going to click Continue, and let's see how long this takes. Boom, done. You think, man, that was fast, right? Well, the reason why is, first of all, it can route the top and the bottom, but it also can include these things called vias. And I'm going to just end the job here. You can look at the different versions, and if there's one that you particularly like, you can select that one. This had a small number of vias. So what is a via? Well, a via are these little pads that connect a top trace to the bottom. And that allows the board router, the auto router, to route around ways that you couldn't possibly do with a single-sided board. You'd actually have to have a wired jumper on the other side of the board. So once that's done, it's a little hard to see what everything looks like with all the traces on there too. So I'm going to temporarily turn those off. I'm going to go to View, Layer Setting, Top, Bottom, Pads, Vias, and click OK to kind of get an idea of what the board is going to look like, just the silkscreen layer. So that's what your board would look like. With the single-sided board, the way that we're going to manufacture it originally, you would have no silkscreen. So this will be nice to actually have a silkscreen on the board. Okay, I'm going to go back to View here, Top, Bottom, Pads, Vias. And then I'm going to go down here to DRC, click on that, and check it. And if everything's good, there should be no errors. You see down on the bottom it says no errors. Good idea now to also check the ERC again. Now it automatically goes back to the schematic, and none of these are errors at all. I could clear them all. But none of these are errors that are going to cause any issues. So that's it. Whoops. Oh, I must have only selected, I left off the top. Gosh, that threw me for a second there. And I'm also going to rename this, instead of bottom only, I'm going to rename this 555-4017 DS for double-sided. I'm going to also ask that you put either your first, well, let's make it last name, something like this. so that when I'm looking at your boards, they're not all named the same thing. Too many times I'm working on board files and they're all named ELTN 115 project or flasher or something. Make sure your name's included in there, because I'm planning on ordering boards, and hopefully we can order these boards and actually use them for the lab. Okay, so if you have any questions as I went through that, feel free to email. I'm going to post this at the end of this unit, but once you've done, and I'll send an announcement, so you'll have seen the announcement before you start on this. But I'd like you to see if you can do this double-sided board. Next week, what we're going to look at is surface mount technology, which can make things even smaller yet. But this, I just wanted to be able to have, we're going to kind of walk this in steps, going through the process steps of going from single-sided to double-sided, and then to surface mount technology.